Okay, the first section of Chapter 7 is going to deal with completing the square. So the first set of exercises just remind you of what you learned in the previous chapter. So to solve quadratic equations, the first example up here, you have a square equal to 6, so you're just going to take the square root of both sides. So the square root of x squared is equal to the square root of 6, giving us x equals plus or minus 6. Now the plus or minus happens to be important here because we're dealing with an equation and we're solving it. And it is a quadratic, so we'll have two roots. So in this equation, we have a binomial square, so we're just going to take the square root of this side and take the square root of this side, which gives us x plus 1 on the left side is equal to the square root of 6. Well, now to find x, you just subtract 1 and we get x, forgot the plus or minus, is equal to minus 1 plus or minus the square root of 6. So you really have two answers here also. In this case, we square the left side and we get 3x plus 4 equals plus or minus the square root of 6. Subtract 4 from each side, minus 4 plus or minus the square root of 6 over here is equal to 3x. Divide both sides by 3. X is equal to minus 4 plus or minus the square root of 6 all over 3. Now, in case you didn't know, do not cancel the 3 out into the 4. Even if they could cancel here, you don't want to do that because you don't have a leading coefficient of this root 6. So this is the case where you can't cancel. Now in this example, when you take the square root of both sides, obviously you're going to be taking the square root of negative 4, which you can't do, so you have that imaginary unit. So the square root of x squared is just x, and the square root of negative 4, no. Now in this case, when you take the square root of x squared, you're going to get the square root of negative 4. So now we have, this is really equal to the square root of negative 1, which is I, times the square root of 4, which is plus or minus 2. So we get plus or minus 2i. For this one, when we take and square both sides, you're going to get x plus 7 equals, and when you take the square root of negative 4, you're again going to get minus 2i. So you have to bring the 7 over, x is equal to minus 7 plus or minus 2i. And that one's finished. Now, on this one, squaring both sides gives you 2x plus 7 on the left side. Or, I'm sorry, not squaring, taking the square root of. And take the square root of the right side. Again, we get plus or minus 2i. So we have 2x equals minus 7 plus or minus 2i. And then dividing by 2, we get x equals minus 7 plus or minus 2i. All over 2. Now you might again think you can cancel it into here. You cannot because the 7 is not divisible by 2. Now for this problem, when you take the square root of both sides, you get t minus 3 equals plus or minus the square root of 8. Add 3 to both sides. T is equal to 3 plus or minus the square root of 8. Well, the square root of 8 can be reduced to, remember there's a 4 times 2 in there, and 4 is a perfect square, so we're going to bring out the 2. So it's 3 plus or minus 2 root 2. Okay, for this example, the first thing you want to do is you want to divide out that 3 because you want a perfect square over here. So when we divide this side by 3, we just get y minus 2, quantity square, is equal to negative 4, because negative 12 divided by 3 is negative 4. Now if I take the square root of both sides, I get y minus 2 is equal to the square root of negative 4, remember, is plus or minus 2i. And so now we're going to add 2 to both sides, and y is equal to 2 plus or minus 2i. Now here's our first example where we're going to be expected to complete the square. Completing the square just means that we need to get something. If you'll notice that this is one that in the past you haven't had any way to factor, because this actually you would have written that it was prime, so you really had no way of doing this. So what you're going to do here is you're going to complete the square. And what that really means is I need to get something, get rid of your constant term and get it on the other side. So when I move the 5 over to this side, what I really need is I need something in here. I need to put another constant term in here to make this side a perfect square binomial. Well, the x part is easy because I don't have any leading coefficient, which would have been our first step, which we'll do one like that. So once you get the leading coefficient off, and this one didn't have one, then we're going to put something in here that's going to make this a perfect square. Well, think about it. If I had x plus 1 times x plus 1, I'm going to get x squared plus 2x plus 1. Well, that's not exactly what I want. I want minus 2x. Well, the only way to get a minus 2x for my middle term is x minus 1 times x minus 1. Then I get x squared minus 2x plus 1. Right? So this is what I really want to be able to factor it into the perfect square. So what I'm going to do is I'm going to make the left side look like this. To do that, I have to add 1. Well, if I add 1 to this side, I have to add 1 to this side. And that's a key point because don't forget, you can't just fool around with this left side and not do the same thing over here. So now, this side will factor into x minus 1 squared. Okay, let me get this out of the way. And that's equal to 6. So now I take the square root of both sides. X minus 1 equals plus or minus the square root of 6. So now I just add 1 to both sides. X is equal to 1 plus or minus the square root of 6.